Okay, so we're going to continue here solving equations. Now in this video we're going to go over factoring a trinomial and then solving that equation. Okay, so for instance here we have this equation and we want to factor it in order to solve it. Now I can't start right away trying to factor this, right? Again, one thing you have to remember here is that this -4, right? It must be 0 on this side of the equation. So I have to do something about this -4 first. Right, and what I'm going to do is I'm going to add 4 to both sides of the equation. All right, so what that does is that becomes 0. So I have 0 on the right side of the equation. Good, and here, -5 plus 4 is a -1, and then everything else remains the same, right? Since that's like term with the -5. Okay. All right. So now once it's set equal to 0, all right, now I can use the that 0 property when we have factors that multiply together. All right, so factoring this, I could see, all right, we want something that multiplies to -2, but adds to 1. I think here we can do this right off the bat, right? I think here, only one possibility here to write the factors of, integer factors of 2, just 1 and 2. The plus sign would go here, and the minus sign goes here. All right, and again, right, as I do this, I've done, who knows, thousands of these factoring, right? So once you do as many as I have, you kind of start to see where things fall into place. But something like this, pretty straightforward, right? So I know there's not much options, right? This one of them has to be 2, one of them has to be 1, and for the last term, it must be both of those must be 1. The only thing that comes down to here is, well, plus minus. How do I know to put that one? Where to put the minus? Where to put the plus? Right? And they have to be mixed signs, right? Because when you multiply opposite signs, a plus and a negative, you need that negative there. All right. Now the middle term is positive, so I want this 2 sign to be 2 sine of theta to be positive, right? That's why the plus sign is here. That way, when I multiply the inner terms, I get negative sign. So 2 minus 1 gives me that positive 1. Okay. All right. So now we're pretty much all the way there. All right. We have 2 factors, right? This is one factor, this is my second factor, and it's equal to 0. So what must be true is that one of those has to be equal to 0. So 2 sine theta minus 1 equals to 0, or sine theta plus 1 equals to 0. And then I'll solve each one of these separately. All right, and then that'll give me my solution set for my original problem. Okay, so here we add 1 to both sides. That goes to 0, and we get 2 sine of theta equals to 1, or sine of theta equals to 1/2. All right, sine theta is positive in quadrant 1 and in quadrant 2. All right, and then here we see, okay, sine 1/2, that is a reference angle of pi over 6. So pi over 6 here in quadrant 1 is one of the solutions. The angle over here in quadrant 2 will be 5 pi over 6. All right, right from our unit circle. 3, 4, 2, 1. Okay. All right, so now for this one, subtract 1 from both sides. Sine theta equals to -1, right? And again, sorry, before I jump ahead here, these are the only 2 solutions since we are dealing with the interval 0 and 2 pi. All right, sine theta is equal to -1, and we could see here in the 0, 2 pi interval, that only happens down here, right? It's +1 here, but -1 down here. It's a quadrantal angle, right? So here theta is equal to 3 pi over 2. All right, so we have our solution set. All right, our solution set is 5 pi over 6, pi over 6, and 3 pi over 2. Okay. All right. So again, just to review here, in order to use this factors and set each one of them equal to 0, it must be initially set equal to 0, right? You have to do this first. It does not work for any other number, right? Does not work for 1, 2, -1, -2, right? It just does not work that way. All right, only 0 has that property. All right, let's do one more example here. All right, how about same idea here? We're gonna solve for 0 theta less than 2 pi. All right, and here we'll have 3 cosine theta plus 2 is equal to 3 plus 2 cosine squared theta. All right. Okay, so again, before I move any further, right, I want to, or before I even think about factoring, I want to make sure that this is set equal to 0. So I'll start by subtracting 2 from both sides and subtracting 3 cosine theta from both sides. There's no like term with the cosine theta, right? Remember, cosine squared theta, not a like term with cosine theta. So I'll just write it here at the end here. All right, remember here we're just adding and subtracting, so I'm just going to rearrange some terms. So on the left side, both of those go to 0. So 0 plus 0, 0. Here I'm going to write the leading term to be the squared. Right, I'm just going to do that right away. Whenever I'm factoring a trinomial, right, just my mind is set up that the first term should be the square, the second term should be the linear term, the one with the first power, and that's going to be minus 3 cosine theta. And then the last term should be our constant. In this case, 3 minus 2 is a positive 1. All right, I just rearranged the terms, right? I didn't, and then I combined the 3 minus 2. Okay. All right, so now in this case here, we have 2 cosine squared minus 3 cosine theta. Again, when I see this, I said multiply it to 2 and add to a negative 3. All right, when that last term here is positive, there's one of two choices. They either both have to be plus in our factors, or they both have to be minus, right? They have to be the same sign, right? Because it's positive. Right now, how do I know which one to choose? Well, that depends on this middle term. That middle term is minus, so when I add those middle terms up, they must be negative. So the only way I'm going to get a negative is if they're both minus, right? 2 positives is just going to give me another positive number. And here, this one can only be split up one way. 2 cosine theta and cosine theta. Right, and this, again, only one option here, right? So this one almost factors itself. Again, once I understand what it is that I'm doing and how I should place these terms here. All right, see, look, the first term, 2 cosine squared, check. Negative 2 cosine minus another cosine, negative 3 cosine. Last term, negative 1, positive 1. And of course, equal to 0. All right, excellent. All right, and now we have what we want, right? We have a couple of factors, factor 1, factor 2, set equal to 0. All right, so there's now I can use that property, right? If that's equal to 0, what has to be true is either 2 cosine theta minus 1 is equal to 0, or cosine of theta is equal minus 1 is equal to 0. Okay, and let's solve each one of these individually here. So I'll add 1 to both sides. 2 cosine theta equals to 1, divide by 2, and we get cosine theta is equal to 1/2. All right, cosine is positive, and that happens in quadrant 1 and in quadrant 4, right? For 1/2, our reference angle, in this case one of the solutions since it's positive, it's a reference angle and a solution, and that's going to correspond to pi over 3. Right, from our unit circle, which means that here, right, not quite 2 pi, right, 2 pi would be what, 6 pi over 3, but we cut off a pi over 3, so this is going to be 5 pi over 3. Okay, so that solves for this factor. For our second factor, we add 1 to both sides. And we get cosine of theta is equal to 1. And this will be a quadrantal angle. Cosine of theta being 1 happens out here. And that would be when the angle is 0. Right? Or 2 pi, but again, 2 pi falls outside of our, it's the border of our interval. So we just have one solution. So the solution set, one solution, excuse me, for this equation. The solution set is 0, pi over 3, and 5 pi over 3. Okay. And that's how you solve by factoring here. All right. Thank you.